So in this part of the lesson, we will focus our attention on continuous income stream. Okay, so at the end of the lesson, here is the goal. At the end of the lesson, you'll be able to perform computation involving interest compounded continuously and continuous money flow, find the present value of an investment, and find the accumulated or future value. This accumulated present value of an investment means it's called the future value of the investment. I believe in your high school or pre-calculus, you already solve problems related to compound interest. Okay, so for example, if you have P represented, principal or initial investment is represented by P, and R is the annual interest rate expressed as a decimal is represented by R. And if A of T be the amount or the accumulated value after T years, then compounding n times. So if the interest compounds n times per year, then here is the formula. And if the interest compounded continuously, then here is the formula. These are the two formula I believe you have already done in your high school or pre-calculus. Okay. Now remember one thing. We are talking about continuous income stream. So we'll be looking this situation in a different perspective. So let us define what this continuous income stream actually means. Now remember, so in this case, in both of the cases, if you are using formula to find what an account will be worth in the future, and AFT is called the future value, like I said earlier, whereas this P is called the present value. But in some situation, money flows into and out of an account almost continuously over a certain period of time. For example, if you look at the parking meter, so people come and go, they put the money and they come and go. So it's just on a regular basis, there is the money flow. Okay, you are putting the money, the customer are putting the money in the parking machine. In the same way, if you look at the banking transaction, cashier, for example, in some store, so lots of customer, they just buy things and they give money on a continuous basis, even though it's not continuous, but we can consider that as continuous because it just come and go. So the flow of money in such cases is not exactly continuous, as I said earlier, but it can be treated as though it were continuous. And on this assumption, we can come up with some very powerful formula. Okay, so here is the definition of continuous income stream. Suppose money can earn interest at an annual interest rate of R compounded continuously. Let f of t be a continuous income function in dollars per year that applies between year 0 and t. Now the total money flow is given by this formula, 0 to t f of t dt, and present value of the money flow is given by this formula, and future value of the money flow is given by present value, or you can simply write P E sub RT. So it's the same formula that we'll be using. Look at this. Okay, this is P E R T. Now, a lot of talk. Now let's look at one example, and hopefully with the help of this example, you'll understand, even if you didn't understand the things quite well in our discussion. I think this example will help me to make things clear. Let the function f of t be 100. 300 represents the rate of flow of money in dollars per year of a small business. So what is given here is f of t. You can write the capital F or a small f, doesn't matter. F of t equals 300. This is given. Assume a 10-year period. So t is given 10 year. 8% compounded continuously. So R is given 8%, which means you can change it into decimal, which is 0.08. Now find the following, the present value. Okay, let us find present value. So present value is given by the formula, which is 0 to t, f of t e minus rt dt. So that's going to give me 0 to t, t is 10, f of t is 300, e minus r is 0.08 t dt. That's it. So let us find the integration. Okay, I trust that everybody know how to find the how to evaluate the integral of this. Okay, go ahead and try and let me know what is your answer. Okay, guys, I don't have calculator. Help me. How much do you get? Okay, when you so this value will be, so the present value now is if you calculate it, you're gonna get $2,065.02. How many cents again? Let me check in your, okay, I will write 2 cents approximately. Okay, but don't delete the exact value in your calculator because you need that exact value. This is the approximate value, but we need that exact value to find the future value. Okay, part B. So the future value is, this is present value PB and future value FB is given by, you see the formula here, PB times e raised to power RT. So PB, use your use value from your, use exact value from your calculator. Use exact value from your calculator in part A. And times ER is 0.08, T is 10. So then what you get here is, this is going to be whatever that value is. I don't know what is that value. Use your calculator times e raised to power 0.8. And then when you multiply this two value, and let me know what is the answer. It will be dollar, my calculator tells me it is $4,595.78. Did you get the same thing? All right. Okay. Now, I want to add one more question here, guys. Okay, part C. Let me add one more question here. The question is total money flow. Find the total money flow. So let us find that. Part C, total money flow. Total money flow means without the interest. What is the money that you put? If you put $300 per year, okay, you're putting $300 per year for how many years? 10 years. So what is the money that you put in without considering the interest? So by common sense, we can say that 300 times 10 is 3,000, right? So that should be the total money flow. The total money, regardless of the interest, okay, without considering the interest, what is the total money that you put in this scenario, in this situation is $300 every year for 10 years, which is $3,000. That's the answer. But let us use the formula because we want to use this formula here. So the formula here is, let me just copy the formula, 0 to t f of t dt. And 0, t is 10, f of t is 300 dt. So that's going to give me 300t and 0 to 10. So that's going to give me 300 times 10 minus 300 times 0, which is $3,000. And it was expected, right? So we expected that it to be $3,000. So we just use common sense. And using the integration, using the formula, we still get the same thing. Any question, guys, so far? Now, let's work example 2. So example 2, a little bit interesting compared to example 1. Let's look at this. So you have an opportunity to buy a business that will earn 75,000 per year continuously over the next 8 years. Okay, so the money flow is represented by the function. Therefore, your f of t is actually $75,000. So f represents the money flow. So the money that you put in into the account, or you get that amount on a consistent basis, on a regular basis. Okay, so here the business will earn 75,000 per year continuously over the next 8 years. So that is our f of t. And what is t here? How many years? In the next 8 years means t is 8. And what is the rate? Money can earn 2.8% per year. So that is your rate, 2.8%, which gives me 2.8 divided by 100. If you change it, you're going to get 0.028. That is your rate. Okay, so we have all these things that we need. Now, is this business worth its purchase price of, okay, the business currently listed, the purchasing price of the, this business is on sale, and the sale price of the business is $6,300. Now, let us check whether it makes sense or not, whether this business actually is a good deal or not. That's all we need to find. Okay, in the real world situation, what we do is, if you want to buy something as an investment, then you need to check the cash flow, whether that business is actually worth buying or not. Now, in this scenario, we can tell right away. How? Well, let us calculate the present value. And we know the formula. Present value is 0 to t f of t e minus rt dt. Okay, that is the present value. So this gives me 0 to t is 8, f of t is 75,000, er is negative 0.028, t and dt. That's it. Now this is a piece of cake for you. Everybody will be able to evaluate this limit. So let me just copy 70,000 as it is, and then integration of this e raised to power negative 0.028t will be over negative 0.028. Okay, that's it. And then it goes from 0 to 8. All we need to do is evaluate this. 75. So now I can write this as negative 75,000 over 0.028. And then I will have e raised to power negative 0.028 times 8 minus e power 0. And I need your help. Use your calculator and let me know what is the value. Okay, so the calculation, you told me that this is $537,548.75. I didn't calculate it. I didn't use the calculator. I just trust you. Whatever you wrote in the chat box in Zoom, I assume that as a correct answer. But if this calculation is wrong, that is your problem. Okay, keep that in mind. I didn't actually test. I trust that everybody know how to use their calculator to find the value of this. Now the question is this business worth its purchase price? So now what we found is our present value is, we know present value PV of the business, present value of the business equals 537,548.75, and you see the purchase price is 630,000, but the purchase price at present, the value of the business is this much. Now the business actually advertised its price to be $630,000. Is it a good deal? So this is not a good deal. This is a bad deal. You are in a loss. Okay, the actual value of the business is this, but the purchasing price is this. So this is not a good deal. This is not a good deal. As a matter of fact, this is a bad deal. It is a bad deal. Okay, any questions so far? So in example 3, what is given here? Let me read the question first. The company is considering purchasing a new machine for its production floor. The machine costs $65,000, and the company estimates that the additional income from the machine will be a constant $7,000 for the first year, then will increase by $8,000 each year after that. So now this is actually the money flow. Okay, the money flow is first year 7,000. Okay, here f of t is $7,000 for the first year plus $800 each year thereafter. So 1 year, this is year 1. Okay, year 1 is there. And so the remaining, if total number of year is t, then t minus 1 year. For the remaining years, this is the income. So that will be your f of t. Does that make sense? Remaining year. So income function is given by this. Okay. Income is given by this. So remaining years. So if you simplify it, you're going to get 7,000 plus 800t minus 800. So that's going to give me 7,000. No, not 7,000. It is 6,200 plus 800t. So that is our f of t. All right. In order to buy the machine, the company needs to be convinced that it will pay for itself by the end of 8 years with this additional income. Okay. Money can earn, so R is given, which is 1.7%. And T is given 8 years. Okay, you can change this into decimal, which is 0.017. That's what you get. T is 8 years. Okay, now what is the present value? Present value is, remember that you need to look this present value from two perspectives. For the first year, present value for the first year is actually 0 to t f of t. Well, you know what, this one f of t for, let me do one more thing here. Just give me 1 second. Okay, so f of t for the first year is actually just 7,000, and f of t for the remaining year, f of t represents the income, f of t for remaining year, which means t minus 1, is given by this. So the total present value will be, let me write this way. So the total present value will be present value of the first year plus present value of the remaining year. Okay, so present value of the first year is the formula is 0 to t. T is 1 actually in this case. 0 to t f of t dt. E, the formula is e minus rt dt plus present value of the remaining year means the total t is 8. Remember, the total t is 8 years given. We have noted that there. So 1 year already gone. So this is 1 to 8. F of t e minus rt dt. So we need to split into two parts. So 0 to 1, and for the first year, the f of t is 7,000. Maybe, you can represent anyway. That's I think that is clear. R is negative 0.017 t dt plus this guy will be 1 to 8, and f of t for remaining year is 7,000 plus, okay, we already calculated, not 7,000 here, which is 6200 plus 800t e raised to power negative rt dt. R means, okay, let me just plug in the value. R is negative 0.017 t dt. Okay, all we need to do is evaluate the integral. Okay, when you evaluate this integral, you're going to get 7,000 e raised to power negative 0.017 t over negative 0.017, and then it will go from 0 to 1 plus this guy. Let us do one thing. This is actually the two different functions. This, let me evaluate this integral. 1 to 8, 6200 plus 800 t e raised to power negative 0.017 t dt. So let us evaluate this. Notice that this one is your algebraic function. There are two functions multiplied. So what method are we going to use? Use IBP. Okay, use IBP. So that means you can do two ways. You make a table. Let me make a table here, a little bit this side. U, V, so this one is derivative, this one is integration, and here you'll get sine. So derivative, this one is your algebraic, this one is your exponential. So in the Liat rule, which comes first? A comes first. So this is your 6200. I need a little bit of more space here. Just give me 1 second. 6200 plus 800t, and integration here, V is integration, which is e raised to power negative 0.017t. Okay, so if you find the derivative of this, you're going to get derivative will be 800, and then derivative will be 0. So here your integration is e raised to power negative 0.017t over negative 0.07017. And so if you do the integration again, you're going to get e raised to power negative 0.017t over, it will be now positive 0.017 squared. And the sign is positive 1, negative 1, positive 1. Okay. So it's a little bit tricky, right? This question is a little bit tricky than the other one because there are two different scenarios. Okay, now you need to evaluate this integral. So when you evaluate the integral, this guy will be 6200 plus 800t times e raised to power negative 0.017t divided by negative 0.017 plus, no, not plus, minus, because of that sign, minus 800 divided by 0.017 square e raised to power negative 0.017 t. And so this one, and then you have interval 1 to 8. Okay, I leave it to you. So whatever you get, complete that. You just substitute the value now, and you should be able to get it. So this is what we got. Let me just bring it this side. Okay, we have calculate this and calculate that, and then my calculator tells me this value. My calculator tells me it is $70,166 combined together. All right, now let's look at whether it's a good deal or not. This is our present value, and what is the purchase price of this whatever that company is? The purchase price is 65,000. Look at that purchase price. Okay, the cost of the machine is 65,000. But actually the value of the machine, when we calculate, it turns out to be 70,166. So this is actually the, the machine worth this much, but the price is 65,000. Therefore, it's a good deal. Does that make sense? Since the purchase price of the machine is 65,000, but the machine worth this much, 65,000, it is a good deal. All right.